Okay, in chapter 4, we are going to talk about energy. Energy and work are kind of interrelated because in order to do work, you have to use energy. And then another topic we're going to talk about is the law of conservation of energy. So, first off, what is energy? Well, energy is the ability to cause change. It's measured in joules, which is represented by the letter J. So, one form of energy is called kinetic energy. Kinetic energy is the motion of objects or the ability for an object to move. Another type is potential energy. Potential energy is what we know as stored energy. Those are the two main types of energy that we're going to focus on during this section. So before we go any further, I'd like you to pause the video and talk about the different types of energy that you can think about right now in your groups. Go ahead and pause. Okay, some of the energies that you may have come up with were electrical energy, and this is going to be the motion of the electrical charges. This is also the energy that lights our lights up. Probably thought of chemical energy. This is the energy found in stored bonds and atoms, which is released during chemical reactions. Nuclear energy, which is the changes in a nucleus, also what creates nuclear power for us. Thermal energy, aka heat, is the internal motion of particles, and so that's going to give a temperature change for those. Those are our main types of energies. So what exactly is energy? So energy is everywhere. So right now, even when you're just sitting in your seats, you can probably see that the lights are on, or at least the light to the PowerPoint is on. You have heat coming into the room. You have air moving around you. You can maybe hear the wind blowing outside, snow moving. You can see sunlight glaring off of windows. You can hear the hum of the lights above you or the computers in front of you. Well, those are all types of energy. And so everything changes, all these changes that are occurring are involving large or small amounts of energy. Without energy, these changes could not occur. So all changes require energy. When something is able to change in its environment or itself, it has energy. Energy is simply defined as the ability to cause change. Anything that causes change must have energy. So, different forms of energy. Like we talked about before, we have electrical, chemical, radiant, and thermal. These are several common forms. Radiant wasn't on the first PowerPoint, but radiant energy is energy generated by the sun to give off. So here's a question I'd like you to answer. Is the chemical energy stored in food the same as the energy that comes from the sun or the energy stored in gasoline? Go ahead and answer that question now. So, the energy stored in food is chemical energy, so I hope that you got that right. The energy from the sun is typically known as radiant energy, but what you may not realize is that it's produced through chemical reactions. Actually, nuclear fusion is happening, causing large helium to collide with other helium, making lithium and bigger molecules, and so on and so forth, and so that gives off this energy known as radiant energy. And the energy stored in gasoline is typically chemical energy, but is often converted into thermal energy because of combustion reactions. This is also why when you turn your car on and you let it run, it will heat up, blowing out hot air. That hot air is coming from the gasoline reaction or the chemical reaction, which causes a thermal reaction to actually happen. So they're all kind of interrelated with one another. Are they the same? Not precisely, but all are forms of energy and all can actually be linked to one another. Even radiant energy, when we feel it on the Earth's surface, can produce thermal energy, or what we call heat. So these different forms of energy, radiant energy travels from the sun vast distances. Here's kind of the explanation for that. And allows plants to grow. So, because it's allowing plants to grow, it's actually, we have this cool process called photosynthesis that takes radiant energy from the sun and converts it into chemical energy. So we can just convert from one form to the next. So here's an analogy for you. If you have $100, I'm not giving you money, by the way, you could store it in a variety of forms. One being cash, a bank account, which would be electronic, traveler's checks, most of you probably don't know what that is, gold or silver coins. So you can store it in any of these forms. You can transfer that money back and forth in between those forms. And you can deposit your money into a bank using any of those forms of trade for cash or for gold. So, now that we know that all those forms are usable forms of money, regardless, money is money. We can transfer it. Now, the same is true for energy. As long as we have energy, we can transfer it. So energy from the sun that warms you is radiant energy, which is transferred into thermal energy. And we take radiant energy from the sun and we transfer it into chemical energy in the food, which when we eat food from plants, who turned it into chemical energy, we're actually turning that chemical energy from plants into thermal energy. That's why we're warm-blooded, because we give off heat. So it can all go from one form to the next. So let's talk about kinetic energy. Kinetic energy is known as energy in motion. It depends on both the mass and velocity of an object. If the velocity doubles, you will increase your kinetic energy by 4. So it's you have a diagram here that has a truck going 80 kilometers per hour, 2 motorcycles, one's going 50 kilometers per hour and one is going 80 kilometers per hour. Without even knowing the equation, we don't even have to know it. Which one of these would have the most kinetic energy and which one would have the least? I want you to pause the video and answer this in your group right now. Okay, for the most kinetic energy, we're going to see that the truck has it. 1, it has the most mass, and 2, it has a very high velocity. The one with the least kinetic energy is the motorcycle traveling at 50 kilometers per hour. 1, it has the least velocity of the 2 motorcycles, and it has less mass than the truck. So therefore, it would have the least kinetic energy. And remember, kinetic energy is energy in motion. So here's what you need to know about kinetic energy. Kinetic energy, the SI unit for it is joules, abbreviated with J. So if you would drop a softball from a height of 0.5 meters, it would have the kinetic energy about 1 joule before it hits the floor. Here's the equation for kinetic energy, and yes, write it on your note card so you have that for future things like, your tests. So KE, or kinetic energy, is equal to mass 1/2 mass times velocity squared. Mass is always measured in kilograms, and time is always measured in meters per second. So if you're given a mass in grams, you need to convert it to kilograms. Remember, 1 kilogram is equal to 1,000 grams. And if you're given meters per second, you need to convert that, if you're given kilometers per second or kilometers per hour, you have to convert it into meters per second. Remember, there is 3,600 seconds in 1 hour and 1,000 meters in 1 kilometer. Again, write it on your periodic table. Potential energy. So potential energy is pretty much energy at rest. So it's motionless. It's not moving energy. If you have an apple hanging in a tree, it's considered to be kinetic energy. And potential. A lot of times when they talk about potential energy, it's going to be gravitational potential energy. And that's just the energy an object has as it's hanging above the Earth's surface. And so stored due to its position is always known as potential energy. We have 3 main types we're going to talk about. But first, let's talk about this. So PE, or potential energy, stored. So which boulder has a greater potential energy? You don't have to solve any problems for this. You can just tell us by where its position is at on the Earth. Go ahead and pause the video and answer that now. Well, the boulder on the top of the hill would have the greatest potential because it's the highest position above the Earth's surface. What other ways could you store potential energy within this object? Go ahead and answer those questions now. Well, depending on what it is, you could store it in elastic or chemical. So let's talk about elastic potential energy. If you have a rubber band, you stretch it and let it go, sails across the room. Please don't do this. it will gain kinetic energy, but the stored energy that it has before it flies across the room is known as elastic potential energy. So that's where that kinetic energy comes from. It's actually stored in the elastic or the rubber of the rubber band. And so elastic energy is stored by some, and is anything that can be stretched or compressed. Then we have chemical potential energy, and gasoline, which we can burn, or food, which we eat. Both combustion reactions have chemical bonds between them. When the energy stored in these chemical bonds is known as chemical potential energy. When they're broken and turned into something else, like us moving around after we eat food, that's kinetic energy. So energy is stored in these bonds that allow for carbon and hydrogen to be released into the atmosphere. And this allows for us to use those to produce heat, to have movement, but the chemical reaction itself has stored energy in it. We can see that in the diagram here. Then we have gravitational potential energy. This is our position above the Earth's surface. And so gravitational potential energy, or GPE, is when an object has any position above the Earth's surface and it has a gravitational pull on it, which can be calculated using the Earth's gravity, which is 9.8 meters per second squared. GPE's equation is mass times height times gravity, no 9.8 meters per second squared. And so your mass is always going to be measured in kilograms. Gravity is acceleration due to gravity. You should know that. It's not going to tell you in every problem. And then your height, which is always measured in meters. Remember, if it gives you in kilometers, there is 1 kilometer is equal to 1,000 meters. Okay, so according to this, as we change our gravitational potential energy of an object is increased by its height above the ground. So if you have two objects that are the same height above the ground, the one that has a larger mass has more gravitational potential energy. It does not, however, mean it's going to fall to the earth faster. So let's calculate some of these equations. So let's start here. Gravitational potential energy, so it's, remember, mass times height times gravity. So we are given the mass of 3 kilograms. Okay, that's right, kilograms is where we need to be. We are given a height of 20 meters. And we are given gravity, which we do not have in the equation but should know is 9.8 meters per second squared. So we're going to find GPE. So I want you to pause the video right now and use the equation you have for this to solve. Alright, so mass times height times gravity. So we take 3 times 9.8 times 20 and we get 588 joules. And so that's how we calculate GPE. Let's do kinetic energy. So the crow, from the same equation above, starts to the chase, or a hawk, and flies at a velocity of 6 meters per second. What is this kinetic energy? Well, we know from above that it has a mass of 3 kilograms. You have to know that. It has a velocity of 6 meters per second, and we want to find the kinetic energy. So we are going to use the equation 1/2 mass times velocity squared. And so pause the video right now and go through that problem with your group. Alright, so we're going to see 1/2 mass times velocity squared. You have 1/2 times 3 times 6 squared. Now it's 6 squared, it's not the whole thing squared. And so then you'll get 54 joules, and that's how we solve for that. Alright, so you guys have some problems that you need to do on a worksheet, and you also have some questions to answer on Classroom. Have a great day, guys.